Hello! Today we answer the age-old question of what is an x-intercept and why do we care about it? So expectations are to just pay attention and make sure you're pausing and thinking about it, going back and look at your old notes that we took because everything's building. So this lesson today, solving quadratics by graphing, is assuming that you already know how to graph and you've practiced a bunch of graphing. So it's assumed you know how to go boom, boom, boom through those steps, and then now we know how to then go back and solve. So we are going to move into solving right now. I'm excited. Okay, again, we're on page 45. I'm already here, so woohoo! I guess I should show you the table of contents. I should be consistent with all my other lessons. There we go. See the unit. We're on 45. Solve quadratics by graphing. We're halfway through-ish. Depends if you count pages or count lessons. Okay, so solve quadratics by graphing. We have 2 steps. It's so nice. 2 steps. So step 1 is to graph. So we are assuming that you know how to graph. If you don't, look back on page 44. Look back on page 44. And that will lead us into step 2. If you're ever wondering why I go like this, it's because I have clamps holding my phone onto the standing desk because it's a weird setup. And so I have this, like, let's see if I can. I don't want to show you all my scarves. This little black stick. I'm looking through that black stick every single time I look back on my paper. Okay, so step 2, find x-intercepts. And we're going to use x-intercept so often. If you want to abbreviate it with x-int, go for it. So solving quadratics by graphing, x-intercepts are actually really important. If you were launching a rocket, you want to know when it's going to hit the ground. And we can actually do a lot of different transformations to a graph. So if I had, use a pen. So if I have this quadratic, woohoo! So it'd be nice to know, like, we launched the rocket from here. I want to know when it hits here. Great. Awesome. This is nice because it means my output is 0. Whenever it hits the x-axis, means my output is going to be 0. And because I know a 0 is somewhere, it's really helpful because zeros are awesome because they just make things disappear, right? But if I wanted to say, what if this was a basketball and the basketball hoop is up here and I want to know when it's going to hit that location? Well, it's a lot quicker. Okay, you can do inverses and figure stuff out. Like, there are more than one strategy, but there is more than one strategy. But if we wanted to just move this down, what if I instead had graphed it so that the graph looks like this? So it's going to look different because the terms, the units and context are going to look different because it's no longer like 6 feet that I'm launching it at because I'm that tall with my hands. But instead 6 feet is like down here, so it's at -2. But if I make it so that it intersects the x-axis at 0, so my f of x again is 0 because it's an x-intercept, I now have all these extra tools that I didn't have in this first context. So manipulating problems into something we know has a shortcut or a pattern that we like is all about math. If you know patterns that you like, can you take something that's a little more complex and turn it into something simpler or something at least that's approachable? And that's our goal, okay? So we are going to graph and we're going to solve just one example. This whole page is just one example, all right? There's plenty of room. So our example we're working on is with f of x, x squared minus 2x. So if you were labeling this, this would be a quadratic binomial. Our highest degree is 2. Leading coefficient is a +1 that we don't see. And then there are 2 terms, x squared and -2x. So for step 1, we're going to graph. So I'm going to graph in 3 steps. First step is to make sure it's in standard form. So I'm going to get us used to the 0 equals. Just to help you see that. Okay, so sometimes we're going to turn this f of x into 0, and the reason why is because we're looking for x-intercepts. And notice on our x-intercepts, all of our y's or the outputs are at 0. So if it's a good habit to get into of replacing this f of x with 0 when we're solving. Okay, and then a is going to be 1, B is going to be -2, C is going to be 0. Pause. If you don't remember how to find A, B, and C really quickly, then you need to go back and practice that because a lot of this unit depends on you finding A, B, and C. All right? So then B is my axis of symmetry. Again, that formula is the opposite of B over 2A. So I'm going to get opposite of -2 over 2 times 1. Positive, positive. That's a 1. So at x equals 1 is my vertical asymptote. And right, not asymptote, sorry. Axis of symmetry. It's not actually an asymptote. Table and graph. So now I'm going to draw my table. X, Y. Sketch my graph. And I am going to use the pen just because I want to make sure that it is more accurate with my scale. I'm just going to do 5. There we go. And my axis of symmetry is at +1. So at +1, I'm putting that dashed line because this is where I'm starting. So my table, I start with the 1. If I substitute in a 1, I'm going to get 1 squared, which is 1, minus 2 times 1, which is -2. So 1 minus 2 is -1. Okay, if you want to show more work, show more work. It's your notes, but you should be able to substitute in values and get out outputs and graph, all right? This is assuming you've already done that and at least practice it somewhat last class. Okay, so -1, so 1, -1. If I substitute in a, I want to do 0 because 0 is a nicer number than 2. So if I have a 0, I mean 0 squared minus 2 times 0, and then I get the freebie reflection point. If I go to, well, let's go to 3, why not? If I go to 3, f of 3 is going to get 3 squared minus 2 multiplied by 3. 3 squared is 9, 9 minus 6 is 3. So 3 is a 3, 1, 2, 3. Reflection point, it's 2 away, so I'm going to go 1, 2. And I have 5 coordinates, so I'm going to connect the points. All right, so this is my quadratic. I have now graphed it, and now we get to do step 2. All right, so this was all step 1. Step 2, find the x-intercepts. So where does this graph cross the x-axis? And it's nice to know the actual exact locations. So our x-intercepts are at 0 and at 2. Woohoo! Okay, so I am going to show you a little bit, because what's the next lesson? Yeah, we're doing radicals next, but I am going to show you a sneak peek of something. So if you want to be a little bit like curious about what's happening next, great, listen. If not, then skip like a minute and we'll be at the questions at the end. So FYI, if I was going to factor f of x, I would be factoring it and get x and x minus 2. Both of these are called factors. And then when I set them equal to 0, because f of x is 0, and again, if that loses you, that's fine. It's a future thing. I'm just saying for people who already want to look at it or just want to hear some of the vocab as they're going. When I solve this, these are zeros or roots or x-intercepts. And notice how the x-intercepts 0 and 2 are the 0 and 2 that we see here. So factoring it is a nice shortcut for a lot of our trinomial or quadratic trinomials, especially just in general quadratics. But not every quadratic is nicely factorable, so we do have to do other strategies. Graphing would be one of them, but to be more exact, a quadratic formula will be our last lesson, and that's the more exact one. So that is coming up in several lessons, but just an FYI, that's your way you're a little prepared of we have fun shortcuts coming. We did objectives, comprehension questions. Compare and contrast root, 0, and factors. So if you stayed, you've seen these a little bit. So how are they different? How are they the same? Why are x-intercepts such a big deal? You should be able to answer that now. And what are you finding when you solve a quadratic? You should be able to answer that now. So after this, it's all different ways. We're going to do radicals just to make sure you have that in your toolbox, but the rest is just ways to solve quadratics in different methods. So remember that. Look at your table of contents, and we're good. I'm going to cut it short. So, woohoo! Have a great day, and thanks for watching. Bye.